Hello student, today we are going to start our new topic, that is differentiation. See, when we say differentiation, we write the terms like this, dy by dx. Over here, like suppose whatever the quantity is to be differentiated, it is placed over here. It means rate of change of quantity y with respect to x. Rate of change of quantity y with respect to x. Over here we have operator. This is, let us suppose we write dy by dx, or we can write f dash x. So what we have, this is what, f at x plus h minus fx upon h, and we say that limit h tends to 0. Over here we need to know what is the differentiation of sin x. Suppose we have sin x, the differentiation of it is what? See, this is the operator, we'll place the values over here. This is f dash sin x, we can write, and what we can do is that we'll write limit s tends to 0, and what we have, this is sin x plus h minus sin x upon h. Over here what we'll do is that we'll apply the formula, trigonometric formula, that is sin c minus sin d. See, it is coming out to be what? Limit s tends to 0, sin c minus sin d is what? 2 cos c plus d by 2 into sin c minus d by 2. See what it becomes? Limit s tends to 0, this becomes what? 2 cos, this is x plus h by 2, this becomes what? Sin h by 2. We are left with this h also, we'll place. What we have? This is h. What we'll do is that we'll divide and multiply by it to make it like, see, we know the formula of the limit, that limit theta tends to 0, sin theta upon theta is going to be 1. So this becomes 1, and this get cancelled with this. Limit h tends to 0. See, different derivative of sin x is coming out to, because this term is going to be 0. We are just left with what? Cos x. So we say that derivative of sin x is cos x. Similarly, we'll go for derivative of cos x. Over here, all the cases will apply this same principle. This is the method for the finding. See, we have to go for a derivative of cos x. Derivative of cos x delta x f dash x will be what? We'll write limit h tends to 0. We have, this is cos x plus h minus cos x upon h. Again, over here what we'll do is that we'll utilize the formula of trigonometry. What it says? It says that cos c minus cos d is how much? It is minus 2 sin c plus d by 2 into sin c minus d by 2 and upon h. And over here limit h to 0, what we have? This becomes 2 sin x plus x, 2x divided by 2 is x. Over here this is h by 2. What we have? This get cancelled out. What we are left with? This is sin h by 2 divided by h. We'll make it h by 2 and 2. And again this becomes what? Limit theta tends to 0. This is sin theta upon theta is going to be 1. This becomes 1. And this 2 get cancelled out with this. So what we get? Derivative of cos x is minus sin x. Similarly, what we'll go for? Derivative of tan x. This is basically the first principle according to which we are differentiating it out. Derivative of tan x delta x or f dash x. Derivative of f dash x by first principle, basically. F dash limit s to 0. What it becomes? Like we will go for like tan x plus h. This is what tan x plus h minus tan x upon h. See what we'll go for, like we don't have any formula like tan a minus tan b, so we'll go for we will simplify it out. How come? We'll make it into sine theta upon cos theta, and this become again, this is sine theta upon cos theta, this is h. See what we'll do is that we'll take out the LCM over here. It is coming out to be what? This is cos x, this is cos x plus h. So this term will get multiplied by cos x. So what we have? This is sin x plus h. Already we have. It get multiplied by cos x. This is what? Sin x. This becomes cos x plus h. This h I have left it out. Again this becomes, this is what? This formula is sin a cos b minus cos a sin b. So it becomes what? Sin x plus h minus x. This is what? H. This is what? H tends to 0. This is coming out to be cos square x. So what we see that this becomes limit h tends to 0. This is sin h upon h. It's going to be 1. And we are left with cos square x, which goes above and becomes sec square x. So what we get? The derivative of tan x is what? Sec square x. Now we'll go for derivative of cot x. This is according to the first principle. We are solving the derivative using first principle. We are proceeding for derivative of cot x. See what we have. See, this is what fx. This is the operator for all first principle derivative. So what we are doing is that we go for cot x plus h minus cot x upon h. Again what we'll do is that we have to consider that limit h tends to 0. So what it becomes? Again using trigonometrical formula, we'll try to simplify it out. It is coming out to be cos x plus h. This is sin x plus h. This is what? This is cos x. This is sin x. And this is upon h. Again taking the LCM out over here. What it becomes? It becomes sin x plus h over here, and this get multiplied by sin x. This will get multiplied by sin x plus h. So what we have? This is cos x plus h getting multiplied by sin x, and this one getting multiplied by cos x. This is what? Sin x plus h. Viewing this thing, what we are getting? This is upon h. We need to write it out of here. Limit h tends to 0. What it becomes? This becomes sin a minus b. This is what? This becomes sin x whole square. You can write because it is h tends to 0. We have this. See what it becomes. This is minus sin h upon h. Again using that formula, sin theta upon theta, it's going to be 1. And this is sin square x goes upside. It becomes cosec square x. So what we are getting? Derivative of cot x is cosec square x. Now we'll go for derivative of sec x using first principle. Derivative of sec x. What we have? This is f at x is what? This is sec x. We'll go for like operator is same in all the cases. We need not to worry about that. This is what? Sec x plus h minus sec x upon h. Again what we'll do is that we'll convert in term of cos, so it becomes easy for us to utilize the formula. This is sec x is cos x upon h. See again what we are getting? The LCM is cos x into cos x plus h. What happens over here? This get multiplied by this. 1 get multiplied by cos x, and this becomes what? Cos x plus h. And this is h. Limit h tends to 0. See what it comes to be? Cos c minus cos d. Again using trigonometrical formula, what is this? Minus 2 sin c plus d by 2 into sin c minus d by 2. And what do we have? Limit as 0, it is coming out to be what? This is cos square x. This is h. See, we'll see that this becomes what? This limit h tends to 0. This is minus 2. This becomes what? X plus h by 2. This side we have, this get cancelled out. We are getting minus sine h by 2. What we have, we already have h. What we'll do is that multiply and divide by 2 to make it 1. And what we have over here, this is cos square x. This negative and negative get multiplied, become positive. What do we have? This is using this 2 and 2 get cancelled out. What we have? This is sine x and divided by cos square x, which becomes what? It becomes sec x into tan x. Over here we need to be careful that h by 2, this h tends to 0, so it becomes sin x. Now we'll go for like derivative of cosec x. You go for derivative of cosec x. F at x is what? We have cosec x. F dash x is what? We have, this is cosec x plus h minus cosec x upon h. See, again what we'll do is that we'll make it in term of sine. This is sine x minus h. This is what? Sine x upon h. See, what we'll do is that we'll take out the LCM. It is coming out to be what? Sine x into sine x plus h. So over here what we'll get? This we'll get sine x, and whatever over this side we'll get sine x plus h. This is h. Again what we are getting? Sine c minus sine d. It is what? 2 cos c plus d by 2 into sine c minus d by 2. This is what? Limit s tends to 0. What we can do is that we can make this as sine square x, and this is our h. So over here what you see there, this is getting cancelled out. This is coming out to be minus h by 2. So this is h by 2 into 2. What we get? This get over here we need to simplify it out, because this one is like 2 cos x, and this is coming out to be minus sine h by 2. What do we have? We have taken it out as h by 2 into 2. Over here what we have? This is sine square x. So it is coming out to be what? This get cancelled out. This becomes 2 get cancelled out. What do we have? This is cosec x into cot x. So in general what we are doing is that we are taking into account derivative of sin x into cos x. But if they ask to find the derivative of this thing using first principle, then only we'll go for this types of solutions, and it's very useful for the class 11th student. Now like we'll go for derivative of e to power x. Suppose we have like this is f at x is what? E to power x. Again operator is basically the same. It is coming out to what? E over here, limit s tends to 0 will do. Limit s tends to 0. This is what? E to power x plus h minus e to power x upon h. Again what we'll do is that limit s tends to 0. This is what? E to power x. This is e to power h minus 1 upon h. Over here we know that when limit h tends to 0, e to power h minus 1 upon h is going to be 1. So what do we get? This is limit h tends to 0, e to power x. This becomes 1. So we are just left with e to power x. So what we have done is that we have calculated the rate of change of quantity of y with respect to x. We have calculated that. To summarize it out, we'll see that what we have got. We got derivative of sin x is basically cos x. Derivative of cos x, we got it at minus sin x. We got derivative of tan x as sec square x. We got derivative of cot x with respect is minus cosec square x. We got derivative of sec x delta x is basically sec x into tan x. Then we got derivative of cosec x delta x is how much? It is minus cosec x into cot x. Then we did derivative of e to power x delta x is what? E to power x. See, basically there it is basically first principle where we can find derivative of anything through this. But later on what we do is that we go, if they do not ask that, go for the first principle. Basically it is asked in the class 11th exam for to derive these functions using first principle. But later on, like in the class 12, we do not have like first principle to be followed. We go directly into applying this formula. So it is very handy to remember this final formula for the rest of the exam. And that's all for today. We'll meet in the next class. Thank you.